Good morning. My name is Will Montalbano. I am not in Group 2, I'm in Group 3, but I'm not giving my 6-minute talk on centrifugal pumps. So the agenda for this presentation, first we'll go into the different types of pumps, what a centrifugal pump is, the components, how it works, the pump curves, and then we'll relate it to the first law of thermodynamics. So there are different types of pumps. There are dynamic and positive displacement pumps. In dynamic pumps, there's centrifugal and axial. And in the centrifugal pumps, there are single stage and multi-stage pumps. And these stages typically mean that how many impellers are located inside these pumps. Next, for positive displacement, there are rotary and reciprocating. For rotary, there are screw pumps, gear pumps, load pumps, and then for reciprocating, piston and diaphragm. But in this presentation, we're going to be focusing solely on centrifugal pumps. So a centrifugal pump is a mechanical device used to move fluid. It does this by transmitting energy to the fluid to create centrifugal forces that increases the pressure, and this pressure increase creates a difference within the pump that causes the fluid to move from the inlet to the outlet. They are used in different applications such as petrochemical, HVAC, fire protection systems, and also water supply. Here are a diagram of the components of a centrifugal pump. We'll just go over a few of the most important ones. The suction and discharge, as the name entails, the suction is where the fluid enters and discharge where it exits. The casing is what protects the inside components from the outside components, from the outside environment. Next, the impeller. The impeller is probably the most important part of a centrifugal pump, as it is a rotor that contains blades or vanes that create the centrifugal forces located inside the pump that moves the fluid to the discharge. Next, the mechanical seal. The seal is used to basically seal up any of the processed liquid from leaking into the outside environment. The shaft is connected to the motor, and that spins the impeller. The bearings are used to support the impeller as it spins. So how does a centrifugal pump work? So the motor is connected to the shaft, and that is connected to the impeller, and the motor converts electrical energy into mechanical energy to spin these. And then after doing this, it creates a vacuum that draws the fluid into the casing and creates centrifugal forces that causes the processed liquid to be thrown around to the outside of the casing up into the discharge. And I have some kind of animations right here to help visualize that entire process. So now we'll relate pumps to the first law of thermodynamics. So on a pump, we can do an energy balance on a pump to get the above equation. And as we know, the integral is equal to the internal energy plus the pressure divided by density. And plugging that into the above equation, we get the bottom one right here. But as we know from fluids, that pressure is measured in head and for pumps. So using the head equation, head equals pressure divided by density times gravity, we can get the total dynamic head of the pump from this equation right here. And total dynamic head is very useful, especially when looking at pump curves. And as you can see, it does include different types of heads, such as total pressure head, total velocity head, total static head, and also friction head. So as I mentioned before, total dynamic head can be used for pump curves. And a pump curve is a graphical representation of a head, and this is typically provided by the manufacturer and helps relate flow rate, head efficiency, net positive suction head required, and horsepower. So here is a better view of a pump curve. On this slide right here, you have total dynamic head. Right here is ppm flow rate, net positive suction head required, and then right here we have our horsepower as well as our efficiency curves. So as we mentioned before, the total dynamic head is very important when looking at these. So say you're working in a refinery or a petrochemical industry, and you found that your pump is producing a head of 65 feet. We can go into look into this pump curve and figure out the performance characteristics of the pump as it's operating. So with a head of 65 feet, and also an impeller size of 8.5 inches, we can go from right here, draw the line to the right here, and then go down to get the flow rate of 350. And if we look at the efficiency curves, we can notice that there's an efficiency of 77%. And right here is the net positive suction head curve right here. And using that, we can draw the line to get around 6 feet for that. And then using the horsepower, we can determine that it has a 7.5 horsepower rating.